our guest speaker. I did want to make a quick announcement. Next week, we will be meeting at a different location to be determined. And the reason why is there's going to be a space symposium taking place right here. So we'll be in touch with those details. But before, I guess, one possibility we were considering was maybe temporarily having it on a Thursday. Does anybody have conflicts Thursday at 6 p.m.? If so, please raise your hand. Everybody's free Thursday at 6 p.m.? Okay. Odin?
Yes, hello everybody. So welcome to the Malware Club meeting. So today on the main agenda is we have a guest speaker with us, Tarek, who is going to be presenting on malware development. He's going to show you a little bit of like how you would go about creating malware, and this he'll be talking more about that, but that could be useful for several reasons. If you're like researching different techniques that malware authors use, that can be useful for both offensive and defensive purposes. But before we get started with that, I'm just going to go over a couple of like items with you. Let me share my PowerPoint screen here. So we are still looking for officers. I am going to be we're probably going to be finalizing that up. Probably like starting next week, we might be starting to hold elections for officers. So if you're interested in becoming an officer, we already got a couple of people who said that they were interested. So if you're interested, you can email me right here. My email's listed right here. If you're new to Malware Club, so if this is your first time here and you don't yet have a VApp pushed out to you, you can visit join.malware.club right here, and then we will get a VApp pushed out to you. So I think that's all for announcements. So I'm gonna pass it off to Tarek.
Thank you. Hello, everyone. My name is Tarek. I'm a master's student in computer science this year. Today, we will talk a little bit about malware development, how malwares are created. We also have some codes in the end, like just to test it out, see how it works. We have a VApp published for all of you, so you can just get ready and open it up. I mean, we're not going to use it now, but we will use it later. Let me share my screen. The VApp's called malware_development. I hope you guys can see it there. Okay, let's start with a little bit of introduction about malwares in general. They're also called remote administration tools because you use them to control a different hosts anywhere in the world. So back in time, they were called like malwares. Now sometimes they're called RAT or remote administration tools or implants. So you might see that those terms often when you look it up in Google. So implants are the same. Red teaming also use implants to control a computer, or like it doesn't have to be Windows. It could be a Linux or Mac. They're usually written in C and C++, the native codes. They're very flexible to use exe and DLL files. We will talk about that later. Also here we'll cover the C2. What is the C2? How to send connection back and forth to the C2. This is a command and control. I have two samples on the VApp. One of them is on the Windows side, which is the actual implant. it's not doing anything malicious yet. It's just a sample code of how it's written. And on the Linux side, there is a Python code, which is using Flask as a web server to receive connection from the implant. So some of the techniques command and control is using, like the beaconing. The beaconing is used to just to keep sending traffic. It's like a signal. It comes from the name beacon. It's like signaling back to the C2, just to make sure that there's a target that's compromised somewhere in the world, and this target has a certain like the Windows or the operating system type, and like the how many processors on this computer, memory, all of these information. It's useful like later if you want to use it for maybe mining or something like that. You need to know how many processors there. Is it using a virtual box or these very useful information. The second technique is called a dead drop. And the third one is long polling. We will take a look at each one of these. The main protocols that we are using is TCP and UDP. I'm not using UDP here, but we will use TCP. Some malware authors, they use ICMP to send traffic, but it's not recommended, to be honest. One of the reasons why is because sometimes like a security admin will disable the ICMP, like the echo requests coming from the host to outside, but they mainly don't disable the web requests. So web requests or DNS is kind of old, kind of classic now. Not a lot of people using it. Some of the examples using the beaconing, which is the traditional way, is a Cobalt Strike, Meterper, Puppy, and Empire, Covenant. They're all using the beaconing technique. The dead drop, which is using an external or third-party website to communicate to your C2. This is more complex, but it's very useful. Like some of the botnets use RSC and Twitter to do that. Cobalt Strike also has an optional to use external C2. GCAT, it's like for Gmail. In 2017, I wrote a script in Python that will use Gmail to communicate as a C2. So basically you're sending the commands or receiving commands through the Gmail. Your implant is going to be on the Windows side or the malware, and it's executing commands and sending the output back through the Gmail. And I had it as like, I had it set up as you can just send a certain title or like the title for the email or the subject. Once the subject is found in your emails, it will open the email and find the command from within the body of the email, execute it and send it back to the same sender. But I just found out recently that GCAT is actually doing the same thing, which is you might find it on GitHub. So it's pretty useful. The cons here is just kind of difficult to develop. You can also use, a lot of people like malware authors use Twitter to embed some of the commands in maybe an image on Twitter, upload the image and then download it and read the shellcode from it. The long polling, which is a technique, if you look it up in Google, it's back at the time people use HTTP and HTTPS to keep the connection or send and receive commands from the C2. The long polling is exactly the same, but once you open a connection back to the C2, you hang on to the connection for as much as you can, which is, this is happening on the C2 side, not the implant. So you open the implant or the malware will open the connection. The C2 will keep it open for as much as it can. Of course, it has a timeout. Once it times out, it will send it again, probably in a random number, maybe in 20 seconds, 50 seconds, or whatever. But when you keep it hang the connection, you can send the commands whenever you are ready. Whenever you have commands ready on the C2 side, you can send it back to the malware. This is very useful because now instead of having like 50 connections in 1 minute or 50 requests in 1 minute, you might have like end up having only 10. So this is very useful in hiding your traffic, or for traffic, not have a lot of traffic from like intrusion detection or something like that. So now we talk about staging. First, like why we have stages. Well, to keep the malware, of course, small. If you look at the interpreter payload, it has a small, like this, the first stage of the interpreter is a small in terms of size, and then it will download more stages later, like DLL files. So same thing in stages. We have like the stage 1, which is the dropper. This is the initial executable that you will execute on the target. This does the initial delivery, and then stage 1 for persistence, stage 2 for interactive, and stage 3 for exfiltration. Of course, the one that's very important here is the persistence, because if you care more about the interactive or exfiltration before the persistence, then if something happens in your code in stage 2 or stage 3, your stage 1 is not going to be executed. And if something happened on the target, like the victim computer, maybe his computer rebooted for any reason, then you basically lost your target. So persistence, stage 1 is extremely, it's very important here. You don't need to miss it, or you don't want to write your code. You need the persistence to happen first before stage 2 and stage 3. That's why they gave it stage 1 right after the dropper executed. Some of the techniques used for persistence is the like DLL hijacking, schedule tasks, COM hijacking, and service creation. Also, we have code caving. So the DLL hijacking, as you can see here, it's like the loading library. When a program loads library to use certain functions from this library, like a DLL file, you can actually hijack this DLL. Like you can create your own DLL to be loaded instead of the other one. So if you look here, you find the search path that's used by Windows. They go in steps in a certain order from 1 to 6. So if you look at the first one, which is the directory from which the application loaded. So if there's an application that's using something into DLL, it will first look at the current directory of where this application is loaded. If it doesn't find it there, it will go through step 2 and until step 6. So if you replace NTDLL and put a copy there in the directory of the application, it will go there. If it finds it, it will load it first, which is a malicious file. The next technique here is just a task scheduler. It's also very important. I need to mention this. That's when you're writing a piece of malware, you try to avoid writing or executing any CMD commands as much as you can. Like task scheduler, you can do that from the command prompt or PowerShell, but try to avoid that as much as you can, because like intrusion detection will see that you're executing cmd.exe with a certain command, like ipconfig or whoami or all these commands. But if you use WinAPI, it doesn't show that. So this is one of the examples of the WinAPI to accomplish the task scheduler. You see here the exec action.path is the path of the file that needs to be executed. Of course, this will be the malware, not Notepad. This is just an example. The service creation, same thing. We're using WinAPI to do that. Still the same thing. You can use it from the command prompt. I think the command was like sc something, sc.exe. Here, just cmd.exe. Again, it's the same example. We're creating a service that will start cmd.exe every time you log on. Service creation is, it's very useful. It's good, like to hide the presence, because not a lot of people are aware of it. If you do something in registry, like the startup key, a lot of people are aware of that nowadays, and they go and look there. Service creation is not very powerful, but it is good. But COM hijacking, it's the same thing. So this happening in the registry, in the CLS ID. It's kind of similar to the DLL hijacking. So when a software component is like accessing a COM object, like when you're loading the software, this is handled by a query to the registry according to a unique identifier. It's called the GUID. So if you, sorry. Yep. So if you replace that key in the registry to something else malicious, same thing like the DLL, it will go find it there. If it finds something else, it will go load it. So this is better than the service creation. Not a lot of people doing it. It's kind of difficult to accomplish, but you'll find a lot of articles in Google talking about how to do COM hijacking. Another technique, which is, I forgot to add it here, is the code caving. I don't know if you guys have heard of code caving before, but code caving is you find an executable file that you put your shellcode inside the executable based on something that is actually happening in the executable. I have a video here that I recorded before how it's done, and I'll play it like in the end, so I don't want to waste your time. Basically, code caving is when you execute this file, it will execute your shellcode inside the file, and once it's done, it will keep continue the execution, the normal execution of the exe file. So you get a shellcode, you get a reverse shell back, and at the same time, the victim, whatever you compromised, he doesn't know anything. He will just keep running the application. So we have a Linux box here, a Linux VM. It's called maldev_remnax. And the other one is the Windows 10. Let me pull that up. Okay, that's good. So let's open Visual Studio. Hopefully everything will be fine and the code will be there. I think I call it like HTTP implant. So once you open Visual Studio, just open the HTTP. So as you can see, the code is kind of long, just doing something very simple, like sending a GET request, like a GET and POST HTTP request. And the more you add to the code, yep. Now to do that in user. Yeah. Is that good? Yeah. So if you look at the code here, I have multiple functions. If we look at the GET function, I think always, no, this is the POST. Well, first of all, there's at the top, there's a WinINet library loaded. And this is the one that we are using. And then there's a POST function and a GET function. I'm trying to get to the GET one. Here it is. The GET function is using multiple Win APIs like Internet Open, Internet Connect, HTTP Open Request, and HTTP Send Request, which is the final one that is going to be used to send the GET content. And then we use like Internet Query Data Available to get the response back and save it. And then we use memset to have a buffer, make it zeros, and then use Internet Read File, this function, to read the content into buffer. And then we assign temp to buffer and we return the temp to whatever is calling this function. So if you look at the main, let's see how we call this function. So we have the IP, which of course has to be changed to match the IP address of your Linux box. I'm not sure if they're all the same or they're different. I'm gonna have to check that. Mine is 103. I don't know if your IP address is different from mine or not. Is it the same or different?
Mine's the same.
Same? Okay. And here I'm just using the file name is different because I have a function called file name. We will take a look at it in a second. But here I have string reply equal, which is a good thing about C++. It's much easier than C. You can just type string and the name of the string versus doing char and a pointer and all these things in C. We're calling the get function, supplying IP and the beacon ID. The beacon ID is something that if you write your C2, like I'm gonna open this one here. So this is the C2 side. I'm using Flask as a web server. This is like how you code it, just a simple route. So the Flask is using routes to like for get and post and to define like what's the route or what's the URI that you want to use. So the first one is we're using the get method for HTTP to connect to /register /ID equal and then less than and then greater than between them is the signature. If you do this, the Flask will understand that the signature here is kind of like a variable, and you can use it later to get what's between those two greater than equal than and less than, I mean. So here we're using ID as the ID of this implant. Each implant or each malware will have its own unique ID that's being used for beaconing purposes. We'll keep sending beacons to make sure that we have an alive malware somewhere. So this will just print received connection from, and then the IP, return 200, like success. We have another one here for CMD. So if Flask receives a connection with the IP and then /CMD/, then it will know that it's receiving some kind of a command that needs to be executed. Here, I am just replacing it with just one command. But in my other project, SR project, I had like a database. This database is fed by multiple commands, and I'm saving everything in the database. And like I mentioned, I save that in the actual HTML. So it's very flexible. You can give it any command you want, and it will just put them in an HTML as in hex color code. But this is just a simple example. Here, the post, like we're telling Flask, if you get anything with the /r, and if it's a post, then get the reply from the data, split that and get it's gonna be like resp or resp equal, and then the data that we are sending back from the implant. So we're splitting that and we get the actual data that we are sending, and then we print the CMD reply. And at the bottom here, you have this line, how to run the Flask, like app.run host equal. Of course, you can make these zeros, 0000, to listen on all the interfaces that you have, and the port 8080, or you can change it. So once this is saved and you run C2, and then we go to the other side here. Before we make a connection, let's also take a look at the post function. The post function is very similar to the get. The only difference is here in the HTTP open request, you supply post. And here it's going to be the URI that you want to use. And then later, when you do the HTTP send request, you will supply the actual CMD in terms of like, it's going to be at like a character pointer. If you guys took CSC 150 and 250, I think you kind of familiar with that. And here's the CMD length, like the length of the command that being sent. So here, if you look at the top, the CMD is equal to RESP. Of course, it can be changed to anything else. This is up to you. So RESP equal, and then I append the reply to the CMD. The reply has the actual data of the ipconfig command. And then after we send, we return this return temp, which is probably the post request is not sending anything back. This is the command execution function that I'm using. I don't have to go through all of it because I just want to save time for other stuff as well. But basically, this will do the popen to open a connection, a pipe to the cmd.exe, like a input and output pipe. Once it's done and successful, it will return the result here on line 68. So this will be executed first. We do the get, we get the command. If you look at the main, we do the get function, and then we do the get underscore CMD. So we do get 2 times, one for beacon, like for the beaconing purposes, and one just to get the CMD. And the other one is the CMD exec function. We give it the CMD that we received from the Flask. And then finally, we do the post. And we're passing the IP and the CMD underscore result. So if we execute this, hopefully it will work. Yep. So if you look at the Flask here, actually gave us the output, like the ipconfig. Scroll up. So here, get request, and this is what's being sent to the Flask, and then the CMD, and then executed the command and gave us the output back. But of course, in a real system, you need to encrypt your output back, like, and convert it into base 64 just to avoid any unnecessary inspection, because it will be like sketchy if you're just sending the result like this in plain text. Have you guys tested that or no? Yeah, just Python and then space c2.py. There's no command. The Visual Studio, I just did debug start without debugging. So another function here is like the download file. So we can simulate that. Let's pretend that we have a file here using simple HTTP server. So now if we want to download a file, first you need to have a file somewhere. This is going to be different from Flask, like touch image.png. Let's also put it in a static, like main dir static. So if you go there and we want to use the download file, the download file is also very similar to the get and the post. I'm gonna take a look at it. This one, same thing. It's using internet open URL, and the create file. I'm using create file to create a file for the downloaded one, like the test.png. So this one will be provided from through the function. And here I'm using the for loop to using the internet read file to read the binary from this file and write it to the target as a test.png until it's the size is we reach the final size.
Is everybody okay now? Do I have any questions for Tarek for what he's been done so far?
I think we have time. I can show you other things. If you guys done with this, let me know. Yeah.
Did you make any changes to the Windows code at all?
Yeah, you can. Like what
I didn't
changes?
know if we did or not. Like when after we ran stuff in Linux.
No, we didn't. I didn't make any changes. So if you run this from this command again, Python C2, is this what you're saying? Like Python C2 on the Linux side,
I think I'm good. I think I'm all right.
and then debug, start debugging without debugging, I mean. Make sure the IP address is, I mean, yeah, I think it should be the same. So let's try this download function. This download file function is taking the string of the URL, like the actual file name. Very slow. Okay. And this URL is being used. Just make this here. And later, if you're using like an older version of Visual Studio, you don't have to do this thing I'm doing here, the W string. I'm just converting type of the string. So if you use an older version, you can just say URL .c_str. You don't have to do it this way. Okay, let's try it. So I just did the build solution and then I'm going to try again. Of course, this one gave me like an error because it was trying to get the other stuff, but I don't care about that. Yeah, I think I just need to comment all the other stuff and do this one first. But yeah, you can play with it with this when you go home, because I want to show you other stuff as well. The most important part is the HTTP request and the post, and how this is done in the Flask. I can show you like the one that I used for the SRI project. So this one I was using like codes, like sending, if the malware is running on the Windows side, I get the type of the Windows and I send it back to the C2, and I have like codes for each one of them here. Yeah, that's fine. I'm not gonna go through the whole code. Just, here, the same thing. I'm using register ID and signature, and I'm using the database to get back the connection and save it. Save like the information about the IP. So now I'm going to show you like how the code caving also works. I have a video here. I'll just give you like a quick So in this example, I was just doing code caving. There's a Python program called Code Miner on the right side here, the top right. You can download that on Kali Linux or something. This will give you like the empty V addresses, like from inside executable file will give you like a certain address space inside this file. Is it? So this will give you, if you run this code miner on a certain executable, it will give you like the empty or not unused sections from inside that executable. So here I was working on PuTTY. Pretty sure if you connected to SSH through PuTTY before, you're aware of it. So some people do the code caving is they change entry point, as I mentioned earlier, and then they make it go right away to the shellcode inside this file. But this is kind of detected. It's not a good technique. A better technique is to find a cave or a section inside this executable that is not used and use it, versus the old technique is to add a new section to the program. But this is detected from antiviruses, so it's better just to find like an empty one that is not used and get the address, like the V address of this section. And this tool gives you like the cave size, where it began, where it ends, and all the information necessary. And this one I used also, I added encryption to the shellcode. I'm just gonna. So I added encryption and decryption also in the shellcode. So once it's done, I get the address of the shellcode that I need to execute. And once you're done, you get the encrypted shellcode. So basically you put your shellcode there and you put the key and you run it one time, it will give you the encrypted shellcode, copy it and paste it. You can do this without leaving the actual program, the PuTTY. So you run the program inside this x32 debug, you let it to encrypt your shellcode, and then you copy and paste your encrypted one, and you override the original shellcode that you have. So if you run it again, basically it will decrypt it. It's the same procedure. Once we're done finishing the code caving, we have this PuTTY-final. So you just run the program as usual. Just to connect, if you look at the right side of the screen, we got like a reverse shell. And also on the left side, it's the program behavior is still the same. You're still give you like login as, and you put username and password and everything. So nothing changed. And this is done through, if I go back to the beginning of the video, like you can actually look at a certain function in the program, like PuTTY. If the program is going to like connect to a certain target, inside PuTTY, there is a connect to. If you do this through find references, yeah, I think it's not here. There's another video that I had before this one. It's like how to find it. So we don't have to, I don't know if you have time or not to do that. It looks weird in the wow, it's so huge. So if you open X32 debug, I think you guys, if you're taking reverse engineering with Dr. Brizendine, maybe you'll work on this later, or maybe WinDebug. If you load any file, like let's say this easy chat. I do right click and then search for all modules, string references. So this will give me all the strings being used inside the program, and I can find a certain string that actually it's linked with a certain action. Like in the case of the PuTTY program, you need to know like what kind of strings that appears in the PuTTY program. When you click connect, when you put the IP and the port and you click connect, it will show you connect to. So we can like search for something like this, like connect to in the strings here, and look at where actually this is being used in the program. So if I look at something like this, for instance, and right click and follow in disassembler, I can see where it's used. And then I can put my shellcode. I can hijack this and change it to jump to your shellcode and come back later and continue the execution when it's done. I'll make sure to upload the video. It's voice narrated as well. It's not muted. And you can ask Odin to, I think I'm going to ask Odin to upload it to the Drive malware, and you guys can watch it later. So. Yeah, I don't know if I have time or not, but I'll just hand it over to Odin in case he wants to announce something or.
Hey, yeah, if you wanted to continue, you can. We can go like up to 8:10, I would say. So if there's anything else that you wanted to cover, you can.
Okay.
We're 7:10 here, 8:10.
We have-
Oh yeah, I'm on Eastern time.
Before we do that, let's see, do we have any questions about malware generation or malware development in general you want to ask? Tarek, anybody in person or online? Just feel free to speak if so. Doesn't have to necessarily be about this specifically.
So just keep in mind, this was just a simple like example of a malware, but if I present next time, I'm going to show you a more advanced technique, but I just want to make sure that you guys are aware of these things, like the basics, the Win APIs. Like we might look at the code caving, how to do that automatically. Like you don't have to do all of this 14 minutes to get a code caving done. So you might do it like automate the process and use this for persistence. like take a program like Notepad, inject something in it, and save the output back as notepad.exe. So this, every time the victim is going to execute Notepad, you get a shell back to your computer. Also, other things is that I don't know if you guys like know them or not, but the Win APIs, once you, for malware analysis, when you load them into a program like X32, like this one, for instance, if I do open, I'm just gonna do, yeah, easy chat. Look at the symbols, and then you take a look at the DLL files being loaded, and this will give you a lot of information about what this program is doing. But hopefully if I present next time, I'll show you how this is like advanced malwares are avoiding this by like creating their own Win functions, like Win API functions that will have a similar structure of these DLLs. So you don't have to go and import these DLLs when you need to do something like the kernel 32, like the git proc address inside the kernel 32 or load library or something like that. It's kind of more advanced. It requires a lot of coding, but if you do it, you might eventually not to see any DLL loaded here. Well, as I mentioned, it requires tons of coding because you're writing your own structures from scratch to use and utilize every single API. Any questions?
Oh, it looks like we have a question in the chat from Almost. He wants to know what is an egg?
Where is that?
In the chat, I'm not sure what he's referring to, but
where did he see that? Maybe he's talking about egg hunting or something.
yeah, that's
similar.
what I was thinking, but yeah, I don't remember you
Well,
mentioning that.
egg hunting is used for, I don't know if you have seen this here, maybe on my desktop or something, I don't know. But this is like a technique for exploitation.
Yeah, egg hunting is a technique that I teach in 748 software exploitation, where basically it makes, instead of a Win API call, it makes a system call, and a system call checks to see if the process memory exists, if it's committed or if it's not committed. Because if you try to check something that's not committed, it'll give an access violation. So it'll just go through the entire process memory looking for if it's committed, and then it'll look for a special tag, like woot woot is an example of a tag. So you can have an egg that is hidden and somewhere in process memory, and you can do this egg hunting, find that woot woot, and then you've found your shell code, which previously was unknown. Egg hunting is a technique that can be effective, but it does take a lot of time, sometimes a very long time. It's not always the most efficient way to do it. Although there can be ways to optimize it. Like for instance, if you have an idea where it might start, then you could plug that information in.
Yeah, I was just kind of asking, like, I don't know where he got this egg from. Like, I don't have a word egg in my slides. Maybe he found it on Google or something. I don't know.
Were you going to ask a question, Max?
I don't think so.
I think in a Malware Club, we're probably going to do a diverse number of different types of topic speakers. Tarek will present again in the future. Probably not next time. I'll probably go back to some reverse engineering and malware. But he definitely will be speaking again later on. If one of you guys have a desire to speak, then that's definitely something that we can make happen.
Yeah, I think we're done.
No
All
more
right, yeah.
questions for Tarek? Yes. Was that you, Odin, or somebody else?
Oh, I was just gonna close, but yeah, if anybody has any questions for
Nobody in
Tarek.
the room is shy? Let me think of some questions. I always ask good questions. Even when we have people like the president or the provost or the dean, I'll sit there and I'll ask like 10 different questions. How long have you been working on malware development?
Probably a couple years.
Where did you get started?
Started with a project using Python, like to create the malware and C2 both in Python, but it doesn't work anymore. But it was very good. One of the pros, Python is very simple and easy to use, but one of the cons is that it will, if you use PyInstaller to generate the malware from Python, which I think I presented that in an offensive security club maybe 2 years ago. It will give you a large file. I've created another one using Python, which is using GitHub as a C2, like you're sending commands through GitHub and the malware will connect to GitHub, get the command and execute it and send it back and forth, which is very good because GitHub is publicly used for, well known for used for malware activities. It cannot be blocked.
How many hours would you say you spent studying malware development techniques and practicing to get to your current level?
Probably, I don't know, it's a lot of hours, but I would just say more than 30 or 40 hours a week.
30 to 40 hours a week for how many weeks? That's a lot of hours.
Well, depends if you're working on a project. If you're done with the project, you can just take a break. If you want to keep going, well, but of course, in this field, that you never feel enough. Like you just keep doing things and you get more ideas and you add it. But of course, you get break between each idea.
I guess my idea here is, if this seems really overwhelming to somebody, just keep in mind this is something he's put a lot of time and effort into. If it's something you really like a lot, you could probably get to his level. It just would take time and commitment, dedication.
Yeah, of course. You can just start with the simple functions like the one I showed you. And then if you're like, okay, now I know how to make a web request. I want to add something more. I want to make it how to execute a command. And then you're done with this. And then you keep adding things. I want to make it more invisible, like make it bypass firewalls, how to make that, research it, and then you add it to the same project. You keep adding functions over functions until you have something working in the end, like something large. But yeah, the key is not to give up. Just keep doing your thing and work on troubleshooting.
So malware, it's cool to make malware or to do implants. You can do it for legal reasons if you're authorized to do purposes, or you're working for the government. If you do it for malicious purposes, that can be a very bad situation. Evan?
Yeah, so I can talk about malware tech, also known as Marcus Hutchins, a little bit. This might be a little shaky because I haven't read his biography in a little bit, but he was a malware developer for a while, and he still does it, but more for the good guys this time. But when he was young, he kind of got mixed up with some bad people and was helping develop like ransomware and rats and Trojans and stuff like that. And then he was actually responsible for helping out fix the first WannaCry issue, I think, where it was like reaching out to a domain to make sure it didn't exist to continue working. And then he just bought the domain and it basically screwed all of WannaCry's infrastructure. But after that, he was actually coming to a hacker conference in the United States, and they found out that he had been developing some malware when he was younger and arrested him. But I think he's out.
Yeah,
now.
they did. Yeah, they arrested him.
Sorry.
He did have to plead guilty and he did get convicted. So that was a mark against him. I think we're about out of time. So I want to close out.
Oh yeah, sure. So yeah, great work, Tarek. Very good presentation. And yeah, and we'll see you next See you in a couple of weeks. Thank you, everybody.